These are four pictures of the supernova Betelgeuse, right, which is the second brightest element of the constellation of Orion.
One of the hardest stars to miss in the night sky is Betelgeuse. However, according to popular scientist deGrasse Tyson, it is time to pay attention to the massive star because it just exploded, signifying that something terrifying is happening.
So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
What is happening to this star, and how does it affect the Earth? Stay tuned to find out. Step outside on a chilly winter night. Look up at the star-spangled canvas of the sky in the constellation Orion, and one star will undeniably grab your attention. It's none other than Betelgeuse, one of the brightest and most exciting stars visible from Earth. Betelgeuse's location is what you can describe as prime real estate in the night sky. Nestled around 650 light-years away from us, every time we gaze at Betelgeuse, we're actually seeing how it looked over 6 centuries ago. Now, let's talk size because Betelgeuse is an absolute behemoth. But get ready to be mind-blown. If you replaced our Sun with Betelgeuse, this star would extend beyond the orbit of Mars. It could swallow the inner planets, including our Earth, without even breaking a sweat. Basically, in the grand cosmic scale of things, our Sun is like a marble compared to the beach ball that is Betelgeuse. Its color is equally as captivating. That deep, ruddy hue isn't just for show. Betelgeuse is a red supergiant, which means it's in the later stages of its life. As stars like it age, they exhaust their hydrogen supply and begin to fuse heavier elements. This process causes them to expand and take on that signature red hue. This red shade also tells us about its temperature. While it's cooler than our Sun, hence the red as opposed to yellow, it's immensely more luminous due to its colossal size. Temperature, size, color, impressive, right? But hold on, there's more. Betelgeuse is also a semi-regular variable star. In non-astronomy lingo, this means it doesn't have a set brightness all the time. Instead, its brightness fluctuates over time. Sometimes, these changes are predictable. At other times, they leave astronomers scratching their heads in wonder. Scientists started paying closer attention to Betelgeuse in 2019 when it entered a puzzling dimming phase. One such episode was in late 2019 when the star dimmed drastically. Imagine peering up at the vast night sky, where a brilliant canvas of stars is painted against the inky backdrop of space, and noticing that one of the sky's most luminous stars has begun to fade. That's exactly what happened in late 2019 when skywatchers observed that Betelgeuse, a red supergiant star in the constellation Orion, was dimming. Not just a wee bit, but to its lowest luminosity in over a century. The astronomy community was abuzz with excitement and curiosity. Betelgeuse, as mentioned already, is one of the brightest stars in our night sky, and it is normally easy to spot. A ruddy, fiery point in the top left corner of Orion, representing the hunter's left shoulder. So to see this stellar behemoth dimming was like watching a lighthouse's light suddenly fade away. Everyone wanted to know what on or rather off Earth was happening to Betelgeuse. Enter the intrepid community of astronomers and astrophysicists. As they turned their telescopes skyward, they had several hypotheses for this dimming phenomenon. Hypothesis 1: cosmic dust. One of the leading explanations for Betelgeuse's dimming pointed to a veil of cosmic dust. But to be honest, this wasn't a new or far-fetched idea. As stars like Betelgeuse age, they can throw off their outer layers, creating dust in the process. It was possible that the star had released a big puff of material that then cooled and formed a dense cloud of dust, thereby obscuring the star's light. In support of this theory, observations from the Atacama Large Millimeter Submillimeter Array, or ALMA in Chile, along with the European Southern Observatory's Very Large Telescope, showed the existence of a cloudy bubble of material surrounding Betelgeuse. It was like the universe had thrown a dust-filled shroud over the star, making it look dimmer than it actually was. Hypothesis 2: stellar pulsations. Stars, though seemingly calm to the naked eye, are dynamic, pulsating entities. Betelgeuse, in particular, is known to have cycles where it expands and contracts. As it does so, the temperature and brightness can change. Some scientists posited that the star had entered a phase of unusual pulsation, making it dimmer. Couple this with the fact that supergiant stars like Betelgeuse can have hot spots or cool spots on their surface, much like sunspots on our sun, and we get a more complex picture. A significant cool spot on the surface, in conjunction with a period of contraction, could indeed account for a decrease in brightness. Hypothesis 3. A combo deal. Some astronomers proposed that a combination of dust production and stellar pulsations could be at play. Imagine Betelgeuse pulsating, releasing a puff of stellar material, which then cools down and forms dust. By February 2020, however, the plot thickened. Betelgeuse began to brighten again, returning to its usual luster. The dimming episode lasted only a few months, but it gave scientists an invaluable opportunity to study the behavior of a red supergiant in unparalleled detail. After months of data collection and analysis, the dust hypothesis emerged as the front-runner. Images from the Hubble Space Telescope showed that Betelgeuse ejected a superhot blob of material into space. This material cooled as it traveled outward, forming a cloud of circumstellar dust. This dust effectively blocked out some of the star's light, making it appear dimmer from Earth. As time progressed and the cloud moved further away from the star, the dimming effect lessened, allowing Betelgeuse to reclaim its position as one of the night sky's brightest stars. It was a galactic game of hide-and-seek that Betelgeuse played, and we on Earth had front-row seats. Betelgeuse, however, was not done displaying its eccentricity. Lately, the luminosity has swung in the opposite direction, shining brighter than ever. Stars are notorious for being drama queens, and Betelgeuse is no exception. Lately, this supergiant has been strutting its stuff and stealing the cosmic spotlight. If you've been glancing up at the Orion constellation lately, you've probably noticed that Betelgeuse is gleaming much brighter than it used to. We're talking megawattage brilliance, the kind that makes astronomers and stargazers do a double-take and grab their telescopes. But what's driving this stellar sensation to increase its wattage? Again, scientists have come up with multiple ideas. 1. The cyclic nature of supergiants. Betelgeuse is no ordinary star, it's a red supergiant. These colossal stars have mood swings, fluctuating in brightness over days, weeks, or even years. These fluctuations are primarily due to internal processes and how the star's energy is transported to its surface. So while Betelgeuse's current surge in luminosity might seem extraordinary, it is in fact part of the star's natural behavior. 2. The big star, big pulse. Stars pulsate, and the bigger they are, the bigger the pulse. As the star contracts and expands, its luminosity changes. The outer layers of Betelgeuse move in and out, just like a breathing celestial giant. This breathing pattern can lead to significant variations in the star's observed brightness. 3. Hotter than usual. At its core, Betelgeuse is a fusion-powered factory. Sometimes the reactions deep within can go into overdrive, producing more heat and in turn more light. When there's an increase in the rate of fusion, the outer layers of the star get hotter, leading to that glorious surge in brightness we're witnessing. 4. Star spots, but supersized. You've heard of sunspots, right? Our sun has them, and they're cooler regions on its surface. But stars like Betelgeuse can have the opposite, hotspots. If there are more hotspots on the surface of the star, they can significantly increase its overall luminosity. Imagine a fireworks display, but instead of just one sparkler, you've got a dozen all sizzling at once. 5. The cosmic conveyor belt. The outer layers of Betelgeuse are bubbling cauldrons of gas. These bubbles transport heat from the star's interior to its surface. When these bubbles, or convective cells, become more active or grow in size, they can bring a lot of heat up to the surface quickly, leading to bright, luminous patches on the star. 6. Gas and dust. Shenanigans. Betelgeuse is known to eject material from its surface, forming clouds of gas and dust around it. These clouds can sometimes obscure our view, dimming the star's light. But when these clouds disperse or move out of our line of sight, the star can appear much brighter. It's like removing a shade from a lamp, letting the light shine unabated. 7. The precursor to the grand finale. Now, here's where things get super exciting. Betelgeuse is nearing the end of its life. And while that might sound sad, in astronomical terms, it's a cause for celebration. The increased activity and luminosity might be hinting at the star's imminent transformation. While we don't know the exact timeline, one day, Betelgeuse will go supernova, and when it does, it'll outshine the moon and be visible during the day. This current luminosity surge could be a sign of the fireworks to come. There's an electric energy amongst astronomers and star enthusiasts. Everyone's talking, speculating, observing, and hypothesizing about Betelgeuse's radiant performance. Telescopes, both amateur and professional, are pointed toward this ruddy star, capturing its brilliant dance across the sky. Every surge in luminosity, every subtle flicker, is a note in the stellar symphony that Betelgeuse is playing. And speaking of supernovas, Betelgeuse has an explosive future waiting. All massive stars, after burning through their fuel, will eventually explode in a brilliant supernova. There is no doubt that Betelgeuse is dying. It has exhausted its nuclear fuel and is now burning heavier elements in its core. This process creates enormous pressure and heat, which causes the star to swell and pulsate. Betelgeuse is also losing mass at a rapid rate, ejecting gas and dust into space. Eventually, Betelgeuse will reach a critical point where its core will collapse under its own gravity. This will trigger a massive explosion known as a supernova. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than our sun will produce in its entire lifetime. So what happens when Betelgeuse goes supernova? Here are some of the possible effects. A bright flash. The first thing we will see is a bright flash of light as the shock wave from the core collapse breaks through the star's surface. This flash will be so intense that it will outshine the full moon and be visible even during the day. The flash will last for a few hours or days, depending on how much gas and dust surrounds the star. A glowing remnant. After the initial flash, Betelgeuse will fade slightly but still remain very bright for weeks or months. It will glow with different colors as different elements in the star's atmosphere are ionized by the radiation from the explosion. The star will also change shape as it expands and contracts due to shock waves and instabilities. Betelgeuse will become a glowing remnant of its former self, slowly fading away. A spectacular nebula. As Betelgeuse fades, it will leave behind a beautiful nebula of gas and dust. This nebula will be shaped by the star's rotation, magnetic field, and interaction with the surrounding interstellar medium. The nebula will reflect and emit light from the explosion, creating a stunning display of colors and patterns. The nebula will also be enriched with heavy elements, such as iron, gold, and uranium, which are synthesized during the supernova. These elements will eventually form new stars and planets in the future. A neutron star, or a black hole. At the heart of the nebula, there will be a dense core of matter left over from the explosion. This core will be either a neutron star or a black hole, depending on how massive Betelgeuse was before it exploded. A neutron star is a ball of neutrons about 10 kilometers across, with a surface gravity of billions of times that of Earth. A black hole is an object so dense that nothing can escape its gravitational pull, not even light. A cosmic ray burst. A supernova also produces a burst of high-energy particles called cosmic rays. These particles can travel at nearly the speed of light and reach far distances in space. Some of these particles may reach Earth and interact with our atmosphere, creating showers of secondary particles that can be detected by special instruments. Cosmic rays can also affect our climate, our technology, and even our biology by altering the chemistry of the air, causing electrical disturbances and damaging DNA. So, what will a Betelgeuse supernova look like from the Earth? One thing is certain. When Betelgeuse goes supernova, it will be very bright. It will be so bright that it will outshine the full moon and be visible even during the day. It will also be brighter than any other supernova ever observed by humans. The brightness of a supernova depends on its distance, its size, and its type. Betelgeuse is relatively close, very large, and likely to explode as a Type II supernova, which means that it will release a lot of energy and light. Some calculations suggest that a Betelgeuse supernova could reach a peak magnitude of -12 or -134, which is about 10 times brighter than Venus. The brightness of a Betelgeuse supernova will not last long, however. It will fade slightly after the initial flash, but still remain very bright for weeks or months. It will then gradually dim over years or decades until it becomes invisible to the naked eye. How will a Betelgeuse supernova affect the Earth? The good news is that a Betelgeuse supernova will not pose a serious threat to life on Earth. It is too far away to cause significant damage or harm. However, a Betelgeuse supernova could still have some minor effects on Earth's environment and biosphere. For example, ozone layer. Some studies suggest that a Betelgeuse supernova could cause a slight depletion of the ozone layer, which protects us from harmful ultraviolet rays from the sun. This could increase the risk of skin cancer and cataracts for humans and animals, as well as affect plant growth and photosynthesis. Cosmic rays. A supernova also produces a burst of high-energy particles called cosmic rays. These particles can travel at nearly the speed of light and reach far distances in space. Some of these particles may reach Earth and interact with our atmosphere, creating showers of secondary particles that can be detected by special instruments. Cosmic rays can also affect our climate, our technology, and even our biology by altering the chemistry of the air, causing electrical disturbances and damaging DNA. Night sky. The most obvious effect of a Betelgeuse supernova will be on our night sky. It will create a new bright star that will dominate the sky for months. It will also change the appearance of Orion, one of the most familiar constellations. Orion will lose its shoulder and look like a lopsided hunter. Moreover, a Betelgeuse supernova will leave behind a beautiful nebula of gas and dust that will glow with different colors for years or centuries. The effects of a Betelgeuse supernova on Earth may be minor compared to other cosmic events, but they could still have a significant impact on us as humans. For example, science. Betelgeuse supernova will be a rare opportunity for scientists to study a nearby star explosion in detail. It will provide valuable data and insights on stellar evolution, nucleosynthesis, supernova physics, and cosmology. It will also test our theories and models of supernovae and their effects on the environment. Betelgeuse supernova will be a boon for astronomy and astrophysics. Culture. A Betelgeuse supernova will also be a cultural phenomenon that will capture the imagination and attention of people around the world. It will be a source of wonder, awe, and inspiration for artists, writers, musicians, and filmmakers. It will also be a subject of curiosity, speculation, and debate for philosophers, theologians, and historians. Betelgeuse supernova will be a catalyst for creativity and reflection.